Hello students. So this session we will do problems on the topic calorimetry. Okay. So what is the principle of calorimetry? Heat lost equal to heat gained. Okay. Then what will happen? This will result in thermal equilibrium. So both of the bodies should have same temperature. So in order to do that, the body with the high temperature will release heat. The body with the low temperature will absorb heat. So whatever heat is lost by the hot body will be the heat gained by the cold body. Okay, finally the temperature of the system will be same. Clear? It will attain thermal equilibrium. Now here the concepts and formulae which we need to use is what? When there is temperature change for a body, for temperature change, the heat required is called the specific heat. Specific heat capacity is the heat required for changing uh, 1 gram of mass by 1 degree Celsius or 1 degree Kelvin. Okay, the heat required to change the temperature of a body, okay, by 1 degree Celsius or 1 Kelvin. Okay, for one for a unit mass, either 1 gram or 1 kilogram, based on the unit. That is what is specific heat. For m mass, we need to multiply this with m, and for delta theta change in temperature, if 10 degrees Celsius, delta theta is 10. 20 degrees Celsius change we need, that is from 10 to 30, we will be putting there 30 minus 10, that is 20, that change in temperature. So Q is equal to mc delta theta. Okay, this is for temperature change. The total heat required is mass into specific heat capacity into change in temperature. And C is equal to 1 in calorie. Okay, 1 calorie per gram degree centigrade. Okay, for water. Okay, and they will be giving this in the question also. And C is equal to 1 by 2 for steam and ice. For different materials, there will be different specific heat capacities. Now, for phase change, so for phase change, the formula which we use is what? The heat required is the latent heat. What is latent heat? The heat required to change the phase. For how much? For 1 unit mass is L. Now for m mass, we will have to multiply with m. Latent heat of fusion is there, or latent heat of melting is there. For ice and water, this is going to be 80 calorie per gram. Then latent heat of vaporization or latent heat of condensation, both are same. For steam water combination, this is going to be 536 exactly. We can use 540 also, 540 calorie per gram. Okay, so based on this we will do problems. We will start with the simple problems and slowly we will increase the complexity. Okay, so this is the first question. Find the amount of heat required to heat water of 2 gram from 10 degrees Celsius to 40 degrees Celsius. So we will be doing all these questions in calorie unit. Okay, not in SI unit. If we use SI unit, we will have to take the specific heat capacity in joules. Okay, so that will involve some calculations. So always, I my suggestion is to do these questions in terms of calorie. Then, if necessary, finally we can convert that into joule. Okay, so find the amount of heat required to heat water of 2 gram from 10 degrees Celsius to 40 degrees Celsius. So here delta theta is nothing but 40 minus 10. We can say 30 degrees Celsius is the change in temperature. Mass is given as 2 gram. Okay. And specific heat capacity of water is 1 calorie per gram degree centigrade. Okay. These are the datas given. So Q is equal to mc delta theta. So this is going to be 2 into 1 into 30. So 60 calorie. So totally 60 calorie heat is required to heat the water. Clear. Now here in this question, specific heat capacity is not given, but generally they will give. I haven't given like that because we know that value, so we will be using it. Okay, that's it. Is it clear? Hope this you understood. Okay, now we will move to the next question. So here heat is given to water because we need to increase the temperature. Next question. Find the amount of heat released. Find the amount of heat released. Okay, in the previous question, suppose if the question, if the options or answers are in joule, then how to convert this into joule? So Q in joule is equal to, just to convert 60 calorie into, multiply 60 calorie by 4.2. So if you multiply with 4.2, we will be getting somewhere around 252 joules. Okay. So the conversion is nothing but calorie into 4.2. We can convert the entire thing into joules. Okay. Now come to this question. Find the amount of heat released for water of 2 gram. Find the amount of heat released for water of 2 gram when water of 2 gram is cooled from 70 degrees Celsius to 10 degrees Celsius. So find the amount of heat released when, okay, water of 2 gram is cooled from 70 degrees Celsius to 10 degrees Celsius. So here the temperature is coming down. Okay, we are reducing the temperature. So heat should be released. To increase the temperature, heat should be absorbed. So we know Q is equal to mc delta theta. How much is the gram? 2. Specific heat capacity of water is 1. Change in temperature is 60. So this is going to be 120 calorie. 120 calorie. Clear? So this is the answer for this question, and this is released. This is released. Clear? Next one. Next question. A heater gives heat at the rate of 100 watt. Okay, so heater gives heat at the rate of 100 watt. It is used to heat 50 gram of water from 20 degrees Celsius to 30 degrees Celsius. Okay, the specific heat capacity of water is given as 4.2. Find the time taken by the heater. We know Q is equal to mc delta theta. Energy is equal to mc delta theta, which is utilized to increase the temperature. So they have given us power 100 watt. Energy by time is power. So P is equal to Q by T. Okay. And mc delta theta divided by T. Now this is clear. Now we can write P is equal to mc delta theta divided by T. This is fine. Okay. So T is equal to mc delta theta divided by power P. So T is equal to, mass is 50 and C is given as 4.2. So here in this type of question, when we need to calculate time, we will be calculating time in seconds. Okay. So we need to convert everything into SI unit for this type of question. Suppose if we need to find the time and all, or if we need to find mass in kilogram or time in seconds, okay, uh, we need to convert this into what? Into SI unit. So I will be using SI unit of all these. So mass is 50 gram. So 50 into 10 raised to minus 3 into specific heat capacity is given as 4.2. Okay, 4.2. So here, okay, yeah, here we need not convert this into what? We need not convert this into gram also, because the specific heat capacity they have given like a 4.2 joule per gram degree centigrade. So we need not 50 gram we can maintain, because that unit will be cancelled off. Okay, so 50 into 4.2 into delta theta is 10, divide by P is 100. Okay, so this 10 can be cancelled off, this 10 50, this can be cancelled off. So 4.2 into 5, we will be getting here 21 seconds. Okay, so this much time will be taken to change the temperature from 20 degrees Celsius to 30 degrees Celsius. So heater will provide heat to water. Heater will provide heat to water and its temperature will be increased. Now what this refrigerator will do? We use fridge at home, right? It will extract heat. When it extract heat, what will happen? The temperature of the part things, it will come down. The eatables or food which we keep inside, its temperature will come down. Okay, and then it stay for longer period. Okay, right. Next problem. Okay, so a refrigerator extracts energy. So this is about refrigerator. Okay, a refrigerator extracts energy at the rate of 100 watt. How much time it will take to cool 100 gram of water from 30 to 5 degrees Celsius? Specific heat capacity of water is also given. So P is equal to again mc delta theta divided by T. So T is equal to mc delta theta divided by P. Mass is 100. Specific heat capacity is given as 4.2 joule per gram degree centigrade into delta theta is 25, divided by the power is 100. Okay, so this we will be getting as 105 seconds. Clear? Okay, are you able to understand? Fine. So this is second category of problems. Okay, first category we just converted so much of heat temperature into higher temperature, how much heat is given. To decrease the temperature, how much heat is taken. Now this is regarding refrigerator, heater, same concepts only, but power is introduced here. Okay, now we will go to another type of problems. Now here, this is mixture. 10 gram of water at 80 degrees Celsius is mixed with 50 gram of copper at 10 degrees Celsius. Find the final temperature of the mixture. Okay, find the final temperature of the mixture. So here, one is hot body, one is cold body. So we know heat lost, heat lost by hot body will be equal to heat gained by cold body. So what is this conservation of energy? Conservation of energy. So this is what we are going to use here. So which is hot body? So what we will do? We will separate hot body and cold body. Okay. Okay, hot body. So hot body is water here and cold body is copper here. Okay. So what is the mass for mass of hot body? 10 gram. Okay. What is the mass of cold body? 50 gram. What is the specific heat capacity of hot body? This is 1. Okay. 1 calorie per gram degree centigrade. The specific heat capacity of copper, actually they will give this. Okay, So specific heat capacity of copper, that will is given as 0.4 joule per gram degree centigrade. And if when they give, they may give for water also, like Cw is equal to 4.2 joule per gram degree centigrade. Okay, this will be given. But we will be using this in calorie for calculation easiness. Okay, so I am going to take this as for this one 0.4 by 4.2. When we divide 0.4 divided by 4.2, for specific heat capacity of copper is 0.4 joule per gram degree centigrade. So suppose if we divide this with the 4.2, we will be getting is this in calorie per gram degree centigrade. So less than zero point 0.1 will come, but I will take just a zero point 0.1. Okay, right. Just a small compromise in the approximation, but it should not be much difference. Okay. Then temperature of hot body is 80 and temperature of cold body is 10. Okay. Now heat. What is the heat lost by hot body? Heat lost by hot body is mc delta theta. Mc of hot body, C of hot body, delta theta of hot body. This is equal to mc delta theta again. So mass of cold body, C of cold body, change in temperature of cold body. Clear? So now we will apply this and we'll get the answer. Okay, so nothing. The heat released by the hot body is equal to heat absorbed by the cold body. That is the concept here. So mc delta theta of the hot body. Okay, so hot body is how much? 10 into 1 into suppose if we consider theta as the temperature of mixture, theta as temperature of mixture, then 10 into 1 into this is hot body, so 80. Definitely for hot body the temperature will decrease, okay, when it releases heat. So 80 minus theta, what is theta? Theta is the mixture temperature. This is equal to the mass of cold body is 50 into, I'm writing 0.1, its specific heat capacity into here the temperature will increase to the mixture temperature. So mixture temperature is theta minus its old temperature, that is the cold temperature is 10. This is how we can equate. Okay, mc delta theta is equal to mc delta theta. When you take delta theta for hotter body, we can take like a higher minus lower. For colder body, we can take like a higher minus lower. So for hot body, higher temperature is its own temperature, but for cold body, the higher temperature will be greater temperature is nothing but the temperature of the mixture. Okay, understood or what? This one. Now if we solve this, we will be able to find theta, that is the temperature of the mixture. Okay, so this is going to be 800 minus 10 theta. This is equal to 5 theta minus what? 50. 50, yes, this is how. So we will be getting 15 theta is equal to what? 850. So theta is equal to 850 divided by 15. We will be getting somewhere around 56 degree Celsius. 56 degree Celsius will be the final temperature. Okay, clear? So here we have taken degree Celsius scale because the change in temperature for degree Celsius, for Kelvin, everything is same. So we have taken in degree Celsius here, calorie, gram. All these are the units. Clear? Any doubt? Okay, please go through this solution. Okay, fine. So 56 degrees Celsius, even if you put joule also, slight variation in the answer will be there, but based, because there will be some difference in the option, so we can choose it. Clear? Fine. Next problem. Okay, so here another question is like a 20 gram of solid at 20 degrees Celsius is mixed with 100 gram of cold water at 5 degrees Celsius. If the final temperature of the mixture is 10 degrees Celsius, find the specific heat capacity of the solid. So this time I'm not going to write separately hot, cold and all. Directly I will be writing MC delta theta, MC delta theta. So left hand side I am going to write MC delta theta of hot body. So 20 into, here I do not know the specific heat capacity of solid. That is what we need to find, into the change in temperature. So initially it was 20 degrees Celsius. Temperature of the mixture is given as 10. So 20 minus 10. Okay, hot body temperature minus mixture temperature. This is equal to MC delta theta of the cold body. So here cold body 100 is the mass into specific heat capacity cold water. I am writing this as 1 into the change in temperature is what? The mixture temperature minus the cold body temperature. Clear? One is hot body temperature minus the mixture temperature. Cold side, the mixture temperature minus the cold body temperature. Okay, fine. So we can find here. Okay, so CS, specific heat capacity of that solid, is equal to what? So here we will be getting 20 into, this is 10, 200. So 100 into 5 divide by, what will happen this side? 20 into CS into 10 is equal to 100 into 5. Okay, so this thing we can cancel here itself. So how much it will come? 5 by 2 or what? Yes, 5 by 2. So 2.5 calorie. 2.5 calorie per gram degree centigrade. This is the specific heat capacity of the solid. Clear? Okay, so heat lost. Okay, heat lost here is equal to heat gained. Fine. Shall we move to next question? Okay. Next one. In a copper vessel calorimeter. Okay, in a copper vessel calorimeter, we pour 20 gram of water at 80 degrees Celsius. Now 100 gram of cold water at 10 degrees Celsius is added to the vessel. Find the final temperature of mixture if the vessel weighs 50 gram. Okay, so the thing is, in a copper calorimeter, we pour 20 gram of water at 80 degrees Celsius. So that is hot water. Now 100 gram of cold water at 10 degrees Celsius is added to the vessel. Cold water is added. Find the final temperature of the mixture if the vessel weighs 50 gram. So here the weight of the vessel is given. Okay, but temperature of the vessel is not given. Okay, temperature of vessel is not given. So what we can take is, okay, sometimes temperature of the vessel also will be given, so that copper and water mixture we should understand the mixture temperature also, and we will have to proceed. But here, since it is not given, what we need to take is the temperature of that hot water can be taken for copper vessel also, because copper vessel will become hotter immediately. Okay, so we can take like that, and the hot body is equal to cold body, then we will finish this. Okay, this is why we are doing, because temperature of the copper vessel is not given, that is why. Okay, so left hand side, 20 gram of water, 20 into its specific heat capacity. Okay, so I shall write, once I shall write the formula. Okay, so mass of water, specific heat capacity of water into change in temperature. Okay, plus mass of vessel plus specific heat capacity of vessel into delta theta is equal to mass of water, that is called here, okay, into specific heat capacity of water into delta theta. So this side it is cold, this side it is hot. Okay. And in a copper vessel, calorimeter means that is a vessel. Okay. We can understand that it as a vessel. Okay. Now, 20 gram of water into 1 into its temperature is 80. Mixture temperature we do not know. 80 minus theta bus plus 50 gram of copper vessel given into its specific heat capacity is 0.1 into, okay, this will be given in the question. Okay, they will be giving, if they are given that in like a 4 0.4. Okay, in the previous question it was given, okay, zero point 0.4 is given, that when we divide with the uh, when we divide this, in order to convert this into calorie, what we do, we divide with the 4.2, and we are getting zero point 0.1. Okay, so that is how we have done. So same way here also we can take like that. Okay, so zero point 0.1 into, here I am going to take the temperature of that vessel also 80 minus the mixture temperature. This is equal to mass of the cold body is 100 into cold body is water itself, specific heat capacity is this, mixture temperature theta minus the cold body's temperature is 10. So this is heat lost, and here heat gained. Okay, so we need to simplify this. This will become 2 into 8 is 16, 1600 minus 20 theta plus this is going to become 5. For 5 into 8, 40, 400 minus 5 theta. This is equal to 100 theta minus 1000. Okay, so this is like 3000 is equal to 25 will go to that side, 125 theta, and we will be getting theta is equal to 3000 divided by 125. This will be around 24 degrees Celsius. 24 degrees Celsius. Okay, so please note it down. Clear? Shall we move to the next question? Okay, so here temperature of 600 gram of water, temperature of 600 gram of cold water rises by 15 degrees Celsius. Okay, when 300 gram of hot water at 50 degrees Celsius is added, find the initial temperature of cold water. Okay, so 600 gram of cold water, its temperature is increased by 15 degrees Celsius. So here change in temperature is given. So when this happens, when 300 gram of cold water at a 50 degrees Celsius is added, we need to find the initial temperature of cold water. Okay, so here just I am going to write hot body and cold body. Okay, now here the hot water mass is 300 gram. This is the hot water mass. Cold water mass is 600 gram. Both of them have a specific heat capacity same. Okay, this is 1, this is also 1 calorie per gram degree Celsius. Here calorie per gram degree Celsius. Now Next one is the temperature of hot body and cold body. Temperature of cold body is 50 degrees Celsius. It is given. So temperature of cold body we do not know. Let us take it as X. Let us take it as X. Now we will apply heat lost is equal to heat gained. Okay. So MC delta theta of hot is equal to MC delta theta of cold. Okay. Now MC delta theta of hot is what? 300 into 1 into here. uh, Suppose if the initial temperature of this cold water is X, then we can say that the mixture temperature is going to be how much? X plus 15. They are saying like temperature of cold water rises by 15 degrees Celsius. We need to be very careful here. We are using higher temperature minus the mixture temperature. So this is what is theta actually. When we used to put theta, that theta is the mixture temperature. So if we need to take X as the initial temperature of the cold water, then mixture temperature is should be X plus 15. That substitution, if we take carefully, we will be able to come out of this question nicely. Otherwise, we will commit mistakes. So 300 into 1. Now 50 minus what? It should not be X. X is actually the temperature of cold water. It should be 50 minus theta. 50 minus theta. So what is theta? X plus 50. I'll write here MC into the higher temperature minus the mixture temperature here is equal to MC into mixture temperature minus temperature of cold water. This was what we were written previously. So same way here, 300 into 1 into 50 minus of X plus 15 here. Yes. Now this is correct. This is equal to 600 into 1 into what? Uh, X plus 15. This is the mixture minus X. Now this is fine. If we come to this correctly, then no worries. Okay. So 300 into 1 here, 50 minus X minus 15 is equal to 600 here into X, and X will be cancelled out, 600 into 15. So 300, okay, into here what will happen? This will become 35 minus X is equal to 600 into 15. So here this will become 2. So 35 minus X is equal to 30, and X is equal to 35 minus 30. This will become 5 degrees Celsius. This is the answer for this question. Clear? So this is mixture, and but here they are asking the initial temperature of cold water. Is it clear? Okay. So till now we have used only MC delta theta. That is, the temperature is increased, temperature is decreased, and those kind of things. Okay. Now we will see the questions involving the change of phase. Okay, slowly we will increase the complexity. You might have understood. So now after this question, we will solve questions related to latent heat. Okay, phase change or change of state. Okay, students. Okay, hope you understood till this. See, children. Now till now we have seen problems related to change in temperature. Okay, now we will do some problems on phase change also, state change, that is ice to water, water to steam, steam to water, water to ice. So if heat is given, then ice will become water, water will become steam. If heat is taken, that is heat is released by the thing, or if we extract heat from it, then steam will become water, water will become ice, likewise it will go. Now we will see certain questions now. Next question is, find the amount of heat required to change 10 gram of ice at minus 5 degrees Celsius to water at 20 degrees Celsius. So here the process involved is, okay, so here this is minus 5 degrees Celsius ice. Okay, so 10 gram. So next state is like if we keep applying heat to it, this cannot become water directly. This will become 10 gram 0 degrees Celsius ice first. So for that, the heat required is what? MC delta theta. We know the heat responsible for changing the temperature. Now, now this is 0 degrees Celsius ice. This cannot become water at 20 degrees Celsius. Instead, this will become 10 gram 0 degrees Celsius water first. So here the heat involved is the phase changing heat. Now this will become what again? 10 gram 20 degrees Celsius water. Okay. And the heat required is MC delta theta. This is how the process will happen. Okay. Now this question we will move slowly. We have moved slowly just for understanding purpose. After that, we once if we are fluent in this conversion process, we will be comfortable. So Q is equal to what? MC delta theta plus ML plus MC delta theta. So corresponding L, corresponding specific heat, the corresponding change in temperature, we will have to substitute. Here simply I have put MC delta theta only. So Q is equal to how much is mass? 10. What is the specific heat capacity of ice? 1 by 2 into minus 5 degrees Celsius to 0. So change in temperature is 5. Okay, fine. Plus ml. So 10 into latent heat of, here either latent heat of fusion we can say, or latent heat of melting, both are same. So latent heat of melting here, so that is 80, plus again change in temperature 10 into the specific heat capacity of water. Water at 0 to 20 it is going, so 1 into change in temperature is here 20. So water at 0 degrees Celsius will become water at 20 degrees Celsius. So change in temperature is here 20. So if we do this, this is 25, and this is going to become 800, plus this is going to be 200. So 1025 calorie heat is required. If we give this much heat, this ice at a minus 5 degrees Celsius will become water at a 20 degrees Celsius. Okay, hope you understood. Okay, please note it down. Clear? Shall we move to the next question? Okay, next one. Find the amount of heat released when 1 kilogram of water vapor at 100 degrees Celsius is cooled to water at 20 degrees Celsius. So here I am going to write the heat directly. Okay, I am not going to explain the process and all. Okay, this is how you should also do. Q is equal to, first, water vapor at 100 degrees Celsius. This must become water vapor, no, water at 100 degrees Celsius. So the minimum temperature of water vapor is what? 100 degrees Celsius. This is at 1 atmospheric pressure. We are considering normal condition only here. Okay. So first thing is ml. Okay, ml. Next thing is water at 100 degrees Celsius will become water at 0 20 degrees Celsius, MC delta theta. Fine. So 1 kilogram, so 10 raised to 3 into latent heat of vaporization is what, or latent heat of condensation is 540. 540 calorie per gram. Okay, so this into 540 plus mc delta theta 10 raised to 3 into water, specific heat capacity of water. The change in temperature is from 100 to 20, so this is going to be 80. Okay, so 10 raised to 3, if we take outside, this is 540 plus 80, this will become 620 into 10 raised to 3, or 620 kilocalorie. Okay, kilocalorie heat is released when this conversion happens. Okay, so now uh, latent heat is also there, specific heat is also there, change in temperature is also there, change in state is also there. Okay, slowly the complexity is increasing. Okay, clear? Hope you understood. Shall we move to the next problem? Okay, yes. So here this question is, a piece of ice of mass 40 gram at 0 degree Celsius is added to 200 gram of water at 50 degrees Celsius. Calculate the final temperature of the mixture. Okay, and comment on the water, water, and ice in the mixture. Okay, so here uh, again the thing is further complex. Now we do not know actually what will happen to the mixture. The all the questions which we have done till now, it was moving in one direction. That is, ice at a 20 degrees Celsius is becoming water at a 20 degrees Celsius. Okay, one side flow. Here the problem is ice is also there one side it is steam. So when we mix it, anything can happen. So we need to predict what is going to be the output, what should be the final temperature, whether the mixture will have water alone, or whether the mixture will have water and ice combination, or whether the mixture will have steam and water combination and all. So, dear children, let me tell you frankly, from this question onwards, till this, it is manageable. But after this, these kind of questions, you need to develop a logic. Okay, I will explain you a method to solve this problem, but still, even with that method also, if you practice a lot and if you develop how to solve this problem with a logic, then only you will be able to attempt this kind of problems. Okay, this is tough ones. Okay, because we need to see both sides. So I shall explain you how to solve this problem. Please be careful. Please concentrate on this. After that, I will do some problems. You try to find more number of problems and practice it and understand this approach, so that the more you practice, the more faster you will become. Okay, so one side it is ice, one side it is steam. Okay, so what I'm going to do, this is just like a trial and error method. Okay, a piece of ice of 40 gram at 0 degrees Celsius. So first what we will do, we will try to convert full ice into water. Then how much heat is required for that? We will write on one side. Another side, we will try to convert the to full water into water at 0 degrees Celsius. Both side we will have to come like this. And finally, we will get an idea what is going to happen. So one side I am going to write Q1. Okay, this side. Okay, the cold side I will be considering leftward, hot side I will be considering on the other side. So Q1, next state of ice is at 0 degrees Celsius. Next state is phase change, that is ml. So 40 into, suppose if full ice melts into water, latent heat of melting is 80. Okay, so this is going to be 3200 calorie. Okay. So full ice to melt into water at 0 degrees Celsius, this much calorie is required. Who should give this? This should be given by the other side. That because they will liberate heat. Who will liberate heat? Steam, hot water, they will liberate heat. We will see what will happen on the other side. So here I am writing QA. One side I'll write 1, 2, 3, other side ABC. So what is the next state on the other side? This is 200 gram of water at 50 degrees Celsius. Let us see how much heat will be liberated if 50 degrees Celsius water, if it becomes 0 degrees Celsius. Let us see. So that is MC delta theta. That is the only possibility. It can come like this. Okay. So 40 into 1 into 50. So this is actually 2000, sorry, uh, 40 into 50 into, oh, I'm sorry, that side the mass of water is how much? 200. Okay, this side it is going to be how much? 200 gram of water. So 200 into 1 into 50. Okay, so we are getting here 10,000 calories. Okay, so one side ice is ready to come to water to 0 degrees Celsius. The other side, if water becomes 0 degrees Celsius, 10,000 calories will be liberated. So if it delivers 10,000 calories, then no one is there to take. This ice to become water, only 3,200 calories is required. Okay, only that much is required. So 10,000 no one is there to take. So what we need to understand is, listen carefully. If hot water becomes 0 degrees Celsius, 10,000 calorie will be released. But no one is there to take that. Thermal equilibrium should be there. It should come to a neutral temperature, common temperature. What will happen? Water will not convert into 50 to 0 degrees Celsius. Instead, water will be converted into how much temperature? How much is required this side? That is 3,200. Only that much will be converted. Okay. Let us see here. So 10,000 calorie, let it be there. This side. What is the next state here? Now this is water at 0 degrees Celsius. Sorry, ice at water at 0 degrees Celsius. Now for water to become this water, what will happen? This water also will increase to some other temperature. Okay, so MC delta theta. Here this one MC delta theta, but not to 0 degrees Celsius. Okay, hot water will not come to 0 degrees Celsius. This cold water from 0 degrees Celsius, it will come to common temperature. Now what we will do? We will equate this ml plus mc delta theta is equal to mc delta theta. Okay, this is hot side, this is cold side. Okay, now let us see. 40 into 80, this will happen for sure, plus 50 into 1 into temperature of the mixture we do not know. That is what we need to find. Theta minus, previously it was 0. Okay, let it be there. This is equal to what? 200 into 1 into, this time 50 minus theta. Only to that temperature of the mixture the conversion should happen, and both of them should be same. Clear or what? Now this is 2200 plus this is going to be 50 theta. Okay, correct or what? Not 50, this is 40. Here there is a mistake. This is 40 gram. Okay, so this is 40. So right, so this is 40 theta. This is equal to 2 into 5. This is going to be 10,000. Okay, minus 200. theta. This theta is the theta of the mixture. So if you simplify this, okay, this will become 6800 divided by 240. Theta will become 28 degrees Celsius. This is going to be the temperature of the mixture. And what all conversion will happen? This will be full water. So water, mass of water of this complete combination is going to be 240 gram. Steam, ice, all this will become 0 gram. Entire thing will be converted into water. I will explain once again. One side it is piece of ice at 0 degrees Celsius. The other side it is going to be what? 200 gram of water at 50 degrees Celsius. So first what we will do, Q1 we will write, ice will convert into water at 0 degrees Celsius. How much calorie is required? 3200. If full water at 50 degrees Celsius, if it comes to 0 degrees Celsius, it will release 10,000 calories. Okay, big difference is there. This side, water at 0 degrees Celsius, definitely it will take some heat and it will convert into water at a temperature. So ml plus mc delta theta is equal to mc delta theta. We will equate, we will find the mixture. Okay, so you must practice these kind of problems again and again, then only we'll get the crux. Next question. Okay, so this one is, a piece of ice of mass 10 gram at minus 10 degrees Celsius is added to 10 gram of water at 10 degrees Celsius. Calculate the final temperature of the mixture and what is the mass of ice or water, okay, that is going to be there in the mixture. Again, same approach. One side we will take cold. So one side it is minus 10 degrees Celsius ice. So Q1, ice to convert into water, first one, ml we will write. So this is going to be 10 into ice to become this is ice at minus 10 degrees Celsius. So what we need to take, not ml, we need to take mc delta theta. First we should change the ice to ice at 0 degrees Celsius. So 10 into 1 by 2 into change in temperature, 10 to 0 degrees Celsius we need to do. So this is 50 calorie. 50 calorie, if it gets, this ice will become ice at 0 degrees Celsius. Let it be there. We will come to this side, QA. Now here, this is water at 10 degrees Celsius. So what is the next state for water? Water can become water at 0 degrees Celsius. Let us see now. MC delta theta again. This is going to be 10 into 1 into 10. This is going to be 100 calorie. Okay, 100 calorie. So if water becomes water at 0 degrees Celsius, what will happen? 100 calorie will be released. So from 100 calorie, 50 calorie this can take. Okay, remaining calorie is there here. So remaining calorie no one can use. So the thing is, it will not become water at 0 degrees Celsius or not. Okay, let us confirm. Okay, so water at 0 degrees Celsius, it will release 100 calories of heat. This side we have made ice at 0 degrees Celsius. Let us convert. Let us see how much heat is required for ice to become water. So that is ml. This is nothing but 10 gram, and the heat required for ice to become water is 80. So 800 calories are required. 800 calories are required for ice to become water completely. Okay, no one is there to supply that much heat. Water, if it becomes 0 degrees Celsius, it can give only 100 calorie. Already 50 calories taken for what? For ice to become ice at 0 degrees Celsius. So remaining calorie on the right side is only 50. With the 50 calorie, how much ice can be converted into water? Only that much can be converted. Okay, so you should understand the logic, children. So here 100 calorie is he is ready to supply if he converts into full water at 0 degree Celsius. So in this process 50 calorie can be given for ice to become water. Remaining 50 calorie is there. With that only ice can convert into water. So what we should do? We should do is mass into ml is equal to how much is available from the other side. Full water, if it becomes 0 degree Celsius, 100 calorie will be released. 50 calorie will be utilized for ice to become water. No, ice to become ice at 0 degree Celsius. Remaining 50 calorie only available. With that much conversion of ice into water is possible. So ml is equal to 50 calorie. M we do not know. Latent heat of fusion is what? 80. This is equal to 50. So mass of ice converted into water is how much? 50 by 80. 50 by 80. So this is nothing but 0.625 gram. Okay. So 0.625 gram of ice will be converted into water and they will come to a common temperature. So final temperature is what? Temperature is going to be 0 degree Celsius. This is one answer. Okay, ice will become ice at 0 degree Celsius. Water at a 10 degree Celsius will become water at 0 degree Celsius. After that, how much heat is available? With that much, that ice at 0 degree Celsius will convert into ice at water at 0 degree Celsius. So final temperature is confirmed 0 degree Celsius only. Now, mass of water is how much? Already 10 gram was there. With this 10 gram, this converted ice 0.625 gram also will come. So 10.625 gram will be the mass of the water. Correct or what? Okay. Then what about the mass of ice? Mass of ice is already 10 gram was there. From that 0.625 gram is now water. So now this becomes 9.375 gram of ice. Clear or what? So this how to do this problem? Just first we should see from the left side. Full conversion we should assume and see. Okay, for ice to become 0 degree Celsius, how much is required? Then we should come to this side. How much energy will be released if water becomes 0 degree Celsius? Then only we will get an idea. 100 calorie. Then we will come and see the next step on this side. For ice to become completely into water, how much is required? 800 calorie. Can the other side supply this? No. No means how much they could supply, only that much will be utilized here. Only that much temperature change or that much phase change will happen. Okay, so that is the logic of doing this kind of problems. Okay, clear or what? Shall we move to the next one? Okay, so this is another question. A piece of ice. Oh, okay, this is same question. Okay, this is same one. Okay, okay, we'll do this one. A piece of ice of mass 5 gram is 0 degree Celsius. Okay, a piece of ice of mass 5 gram at 0 degree Celsius is added to 5 gram of steam at 100 degrees Celsius. Okay, so here ice and steam, the other extremes. Again, same question. Calculate the final temperature of the mixture. Comment on mass of water, steam, ice. In multiple choice question, any of these questions can be asked. The worst case, if they make the topic tough. Okay. So this one, how to do? Again, same way. This side Q1. This side what we have? We have ice at 0 degree Celsius. Let us convert full ice into water. That is ml. So 5 into 80. So this is going to be 400 calorie is required. Okay, the other side, it is steam at 100 degrees Celsius. steam at 100 degrees Celsius. Next state is what? Water at 100 degrees Celsius. Let us put ml. So this is 5 into latent heat of condensation is how much? 540. 540. So this is going to be 2700 calorie. 2700 calorie will be released if steam becomes water. Okay, now we will come to this side. Now one side it is water at 100 degrees Celsius. This side now this is water at 0 degrees Celsius. So let us see whether if this water becomes 100 degrees Celsius, how much heat is required. Let us check this. For that, mc delta theta. So 5 into 1 into 100. So this is going to be what? 500 calorie. Okay, so into once if water steam becomes water at 100 degrees Celsius, 2700 calories available. With that, this ice can become water. Water can become water at 100 degrees Celsius. After that, now the mixture is now water at 100 degrees Celsius. Still 2700 is not required. So from this logic, what we must understand is only 900 calories required for the system for everything becomes water at 100 degrees Celsius. 2700 is not required. So full mass of steam is not required here to convert. Okay, how much mass should convert into how much mass of steam should be converted into water at 100 degrees Celsius? ml is equal to 900 calorie. Only that much mass is required. So mass into latent heat of vaporization or condensation is 540. This is equal to 900. Only that much is required. 2700 is no one is here to take. They already reached where? Water at 100 degrees Celsius. Okay. Now what will happen? Mass is equal to 900 divided by 540. So this will become 1.66 gram. So temperature of the mixture is what? Water became water at 100 degrees Celsius. Steam became water at 100 degrees Celsius. That time thermal equilibrium came. So temperature of the mixture is 100 degrees Celsius. What about mass of water? Already 5 gram ice was there, that became water, plus the steam is converted into water. So 6.66 gram of water will be there in the mixture. What about mass of steam? This is nothing but already 5 was there. From that 1.66 is converted into water. So this is going to be how much? 3.33 gram of steam. Okay, so this much is the mass of the steam and that much is the mass of the water and temperature. So here uh, we cannot directly substitute, or just by applying the concept we won't get the answer for these type of questions. First, what we should do, this is a method which I am following. I will convert first ice into water or ice into ice at 0 degrees Celsius. Right side, I will be converting steam into steam at 100 degrees Celsius. Then next step, I will be doing this side. Next step, I will be doing that side. From there, I will be getting an idea like how much is required for the other part. Likewise, I'm doing. You try this method and try to solve more number of questions so that slowly you will understand how to solve these problems. Okay, right. Fine. So with this question, I am winding up the calorimetry problems. So calorimetry, the concept wise, what we have is this conversion, temperature change, then phase change, all these. Then when we come to the mixture of ice and steam, ice and water, water and steam, we will have to apply this trial and error method and we will come to a conclusion. Okay, so this type of question, definitely you must practice a lot of questions and make yourself in a comfortable position to think like how to approach these kind of problems. Okay, then study well. Goodbye.